Okay, so in this video, we are going to discuss Euclidean geometry. I'm going to go over all the theorems with you. We are going to start with the line from the center theorem. Before we begin, we are going to go over the basic concept which is discussed in the Euclidean geometry. You guys need to know this before we can explore all the theorems in detail. So number one is arc. Arc is a part of a circumference, the edge of the circle, right? So if you look at this part here, this part is your arc. I can even highlight it for you in yellow. So this part here is your arc. The edge of the circle is arc. Then we have segment. Um, a segment is the area between the chord and the arc. It cuts off a slice that is not, you can say, from the center. So that is your segment. So for example, this part here is your segment. Um, this part here is the segment. So I can just write number 2 here. This is your segment. Number 1 was highlighted in yellow. That is your arc. Then we have sector, the area enclosed by two radii and the arc between them, like a pizza slice. So this is like a pizza slice. So these are the two chords and there is an arc between two chords. So this area is a sector. So this is number 3, a sector. Then a chord is a straight line connecting 2 points of a circle. So this part here is a chord, a straight line that is connecting two parts of a circle is called a chord. So this part here is your chord. Sorry about my cursor, it's not working quite well. Okay. Then we have diameter. Diameter is a chord that passes through the center of the circle. It's the longest chord and twice the radius. So for example, from the center of the circle to the circumference is your radius. So if you look at the diameter, it's twice the radius. So this is the half and this is another half. So together this will make your whole diameter. So number 5 is your diameter and this is represented with number 5. Then we have radius. This is a line from the center of a circle to any point in the on the circumference. So this is the from the center of the circle to any point of the circumference. We will say this is your point number 6, that is your radius. A secant is a line that cuts through 2 points of a circle. So on this is the 1 point this line is cutting on, and this is another point the line is cutting on. So this is your number 7, that is a secant, a line that is cutting on the 2 points of a circle. And then lastly we have a tangent. Tangent we already know is a line that touches the circle at exactly 1 point and does not enter the circle. So it is always outside of the circle, and that is your tangent. All right. Uh, okay, what you see on the screen is a cheat sheet. We are going to go through different lesson and we are going to fill this cheat sheet together. So okay, so when we are going to fill this, so first fourth theorem if you see, which is highlighted in the brackets and these are in the blue. So these are all the theorems with the midpoint, and so these are the circle with the midpoint and all the theorem that goes with the circle with the midpoint. We are going to discuss those first. Then the lonely one over here in the yellow is the one without the midpoint. Then on the right hand side in the green, these are your cyclic chord theorems, and the last 3 over there is your the tangent. So we can say these one is a circle with the midpoint. This one here is without the midpoint. Then this is your cyclic chord, and then lastly we have your tangent. Okay, now let's start. So theorem 1. So the first theorem says that the line drawn from the center of a circle perpendicular to the chord will bisect the chord. So this means if you go to the sketch, O is the center of the circle, and then line OM is perpendicular, and then this is bisecting the chord PQ. So now it bisects the chord. OM is bisecting PQ, which means that PM is equal to, right? PM is equal to your MQ, the line drawn from the center of a circle perpendicular to the chord will bisect the chord, and then abbreviation that you can use for the exam is line from the center perpendicular to the chord. So this is your theorem 1. Next, this is the converse of theorem 1. The line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. The abbreviation that you can use here is line from the center to the midpoint of the chord. So if we look at the diagram as well, so we will see that AB is the chord and OM is bisecting the chord. So OM is the perpendicular line that is bisecting AB. So this means then this will form your 90 degrees because AM and BM is also equal. So this angle here is your 90 degrees angle. So this is the converse of the theorem. Line from the center to midpoint of the chord, that is the abbreviation we can write for this theorem. Okay, so now you can see that your cheat sheet already have the two theorem, line from the center perpendicular to the chord and line from center to the midpoint of the chord. It's bisect the chord and this will make your 90 degrees angle here as well. Okay, now we have this question. Km is equal to ml. Give the size of OML. So we are going to give the size of the angle M. So we can say that OM is perpendicular to the KL. The reason, a line from the center to the midpoint of the chord. And this means that OML is equal to the 90 degrees angle because this is perpendicular. We said according to the theorem, OM is perpendicular to the KL and OM is bisecting KL. So this will make the angle 90 degree over here. So OML is equal to your 90 degrees. The next question. OR is perpendicular to PQ. PR is equal to 7 centimeters. Give the length of PQ. So again, OR is perpendicular to PQ, which means this is bisecting PQ and it is making 90 degrees angle. And our PR is 7 centimeter. So this is 7 centimeter. Now we need to find the length of our PQ. So we are going to say RQ is also 7 centimeter. That is line from the center of the line from the center is perpendicular to the chord, and then PQ will be equal to 7 plus 7. That will be 14 centimeters. Because this line is bisecting, this line is bisecting PQ. This means that PR is equal to your QR. PR is already given, that is 7 centimeter. That's why we said QR or RQ is also 7 centimeter, and the reason was that line from the center is perpendicular to the chord. That's why they ask you to calculate the given length of the PQ. So PQ is this whole thing. 7 plus 7 will give you 14 centimeter as your final answer. Next, O is the center of the following circle and AB is a chord. OC is perpendicular to AB. AO is equal to 13 centimeter and OC is equal to 5 centimeter. Now let's write this information down on the screen. So OA is equal to 13 centimeters. OC is equal to 5 centimeter. Now they want to calculate the length of AB. So AB is this, because this OC is bisecting AB chord, which means that CB and AB are equal in length. And then we can highlight this part as well on the diagram. You can see this is the triangle, right angle triangle. A right angle triangle means that we can apply the Pythagoras theorem to calculate the unknown side. So unknown side in this case we have is your this side OA. If we know the value of OA, then what we can do? OA plus the value of OB will give you the total length of AB. Now let's try this question. This is what we are going to say. AC squared is equal to AO squared minus OC squared. We apply the Pythagoras theorem. Why? Because we can see this triangle is a right angle triangle. Now, with the given information, OA was given, which was 13 centimeters, and OC was given, which was 5 centimeters. Now we are going to say 13 squared minus 5 squared will be your 169 minus 25, and AC squared is equal to 144. Now to remove this square, we are going to take a square root of 144 here on this side. Then this will give us AC is equal to 12 centimeter. Now we know the value of this side. We calculated the value of this. This is 12 centimeter, and we said that because AC is equal to BC, the reason was line from the center perpendicular to the chord. That means that AB is equal to BC plus AC, which will be your 12 plus 12. The answer, final answer is your 24 centimeters. So this is how we're going to solve for this question. Okay, now this question. AC is equal to 40 centimeter, BO is equal to 20 centimeter, and AB is equal to BC. And O is the center of a circle. Calculate the length of a diameter CD and then leave your answer in the third form. So let's look at this picture in detail, the diagram. OB is bisecting AC chord. So AC is the chord, and this chord OB is bisecting this chord. Right? Now, if this is bisecting the chord AB and AC is given, AC is 40 centimeter total, and O is the center of the chord, so line from the center of the chord is bisecting. So this means this line here at the point B is dividing this AC in equal halves, which means AB is equal to BC. If AC is 40 centimeter, then this means that this is 20 centimeters. AB is 20 centimeters and BC is also 20 centimeter. And then this BO value is also given, sorry, millimeters, and OB value is already given, which is also 20 millimeters. And we said AB is equal to BC and O is the center of the circle. So because AB, uh, uh, OB is bisecting, or it is perpendicular to the chord AC, this means that B1 and B2 angle is equal to 90 degrees. This is what we figured out just by reading the diagram. We are not solving the question first. We are not looking for diameter CD value now. So because this is 90 degrees, B2 is 90 degree and B1 is also 90 degree. Now we are going to calculate the length of this side, which was unknown. So this side we are going to see what is the value of CD. Okay, so first step to say is OB is perpendicular to AC. This is line from the center to the midpoint of the chord, and BC is equal to 20 millimeter, which is given, and AB is equal to BC. This is also given. So we figured this out using the diagram. Now we are going to apply the Pythagoras theorem. Why? Because OB is bisecting or is perpendicular to the AC. This means that this is a B, angle B is 90 degrees. So we can find this right angle triangle in the diagram. So we can apply the Pythagoras theorem. So OC squared is equal to AB squared plus BC squared. OC squared will be 20 millimeters squared plus 20 squared is equal to OC squared is equal to 400 plus 400. Remember, this was given in the question. Then to remove this square from here, we are going to take the square root on this side of 800, and then we are going to get the value of OC is 20 root 2. Now DC is equal to this DC, OC is 20 root 2, right? Because Um, then we are going to say because OC is equal to the DC, then we are going to say DO plus OC is equal to 20 root 2 plus 20 root 2. That will give you the answer, final answer of 40 root 2. Why? Because this is also representing the diameter. AC is also representing diameter, and we said BC is equal to AB because this OB is bisecting, or it is perpendicular and making 90 degrees, and that's why from this point O, which is O is on the other side of the this is O is the center of the circle, and these are the two radii OC and DC coming out from the center of the circle making diameter. So this means this DO and OC is also equal in length. That's why we added 20 root 2 plus 20 root 2, and that gave you 40 root 2 as the final answer. Okay, example number 4. In the diagram below, AC is a chord of a circle with center O. AC is equal to 48 centimeter. BD is equal to 16 centimeter, OB is equal to X, and B is the midpoint of the line AC. Now we are going to calculate the length of AD. What is the length of AD? This is AD. We are going to find the length of this. Now because we said that OD is bisecting AC, or OD is perpendicular to the line AC, and that's why the reason will be that line from the center to the midpoint of the chord. Now we are going to draw a imaginary line forming a triangle. Now we can say that AD on this side as well, right? AD is equal to AB squared plus BD squared. We can see that here on the diagram, this AB, this AD, and this BD and AD, this is making a 90 degrees angle at B. So this is a right angle triangle. That's why we can use the Pythagoras theorem. So we use the Pythagoras theorem, and we said that AB was given in the question and BD was also given in the question. So 24 squared plus 16 squared will give you the final answer of 28,84 centimeters. Now determine the length of OD in terms of x squared. So OD will be your x plus 16. Why? Because OD is equal to OB plus BD. So OB is x, and BD we found BD was given in the question, that was 16 centimeter. So OD will be total OB plus OBD. So this OB plus your, I'm going to highlight this in green, BD, that will give you x plus 16. Okay. Now, determine the numerical value of x. Now we are going to determine the numerical value of x. Now, we are going to say OC squared is equal to BC squared plus OB squared, which is the Pythagoras theorem. So we did draw the imaginary line going from O to C, and then B to C, and then O to B. So this is another 90 degrees triangle. That's why we use our Pythagoras theorem. So we're going to say OC squared is equal to BC squared plus OB squared, and then OC can be is same as your OD. Why OC is equal to OD? Because remember, O is the center of the circle, and then from the O to the circumference, this is one radius. OD and OC are the radii. So OC and OD are equal. So because we are going to find the value in terms of x, and we are looking at this triangle, we can say that OC wasn't given, right? Because OD was given in the question, we are going to say that, okay, instead of OC, we are going to replace OC with OD because they both are radii and they are equal. So if OC is equal to BC squared plus OB squared, then OD is also equal to BC squared plus OB squared. That will give you BC squared is equal to 24 squared plus OB squared, which was given x squared, and then we are going to substitute this OD value from 4.2. OD was x plus 16, so we said x plus 16 squared is equal to 24 squared plus x squared, and then we are going to solve for x. So x will be 320 divided by 30. 2 in the final answer you will get after you divide 320 by 32. The final answer will be 10 over here. So x is equal to 10 centimeters. Okay, in the diagram, this is example 3. In the diagram below, KT is a chord of a circle O. OC is drawn perpendicular to KT and cuts KT at P. PO is equal to X and PC is equal to Y. Determine PT in terms of KT. So PT, OC, wait. Let me grab a highlighter. So this is OC. OC is perpendicular to the KT and it is bisecting this chord at the point P, at the midpoint, which is P, right? So if it is bisecting chord at this point, this means that KP will be equal to your PT. If KP is equal to KP is equal to PT, we are going to determine the PT in terms of KT. So we are going to say that PT is half of the KT. KT is this whole chord here and PT is the half of KT. So this is how you're going to write this. PT is equal to half KT. This is the reason line from the center perpendicular to the chord. Okay, question number 2 says prove that KC is equal to 2xy plus 2y squared. Okay, so in this question we are going to start with the Pythagoras theorem in triangle KCP. So we are going to say that KC squared is equal to your PC squared plus your KP squared. Okay, so this was Pythagoras. I'm just going to write PYTH Pythagoras in triangle KCP. Then we can say KP squared is equal to OK squared minus your OP squared. This is again, I'm just going to say Pythagoras, and this is when we are looking at your triangle KOP. Now, uh, so this was, if you look at KOP triangle in the circle, we are going to get OK squared is equal to KP squared plus OP squared. Now we move this KP on the other side by making the subject of the we made this the subject of the formula. So we said KP squared and then this OP went on the other side. So OK squared minus OP squared is your KP squared. This is what I got on the in the equation here. Now we are going to say, now in the next step I moved from, let me write this, let's change the color. So we said KC squared is equal to PC squared plus OK squared minus your OP squared. So this was the first step. I went from first step to the next step, and then we said this KP, we are going to replace this KP with this KP over here. So we said I'm going to replace this KP squared, and I replaced this with OK squared minus OP squared. Okay. But OK is equal to your OC, and the reason is radii. Why? Because if you look at this line here, OC is your radius, and if I draw an imaginary line between OK, this is also a radius. So this is, we said OK is equal to OC, therefore they are equal, and reason is because they are radii. Now in the next step we will say PC squared plus OC squared minus OC minus PC squared. Now what I did, in place of OK I substituted this PC. So in place of OK I substituted this PC. Now in place of OP, this is your OP, OC minus PC. So this is OK squared, I replaced with OC squared, and OP, we said OC minus PC. Why? Because look at this, if you look at the sketch, then this is your, sorry, this is your OC, right? And this is your, this part over here is your OP. So if I minus, so the OP is equal to whole of this line OC minus this part here, which is PC. So that's why we said OC minus PC will give you, in place of OP we wrote OC minus your PC. In the next step we are going to say this is equal. Now in the next step we are going to say that PC squared plus your OC squared minus, so if you look at this part, this is similar to the algebraic expression which says A minus B times A minus B, right? So OC minus PC times OC minus PC, and if you solve it in detail, it's gonna give you OC squared minus 2OCPC and plus your PC squared. Similar to the expression, if you solve this, we will get A squared plus sorry, minus 2ab plus your b squared. So similar to the algebraic expression here, we are going to write this, and then we are going to times this minus sign over here, this sign over here, with the brackets. So with this, and then with the this one positive sign here. Next step, PC squared plus OC squared uh, minus OC squared, then plus minus uh, uh, then plus 2 OC PC, this is bracket times minus your PC squared. And now we are going to do the cutting. So plus OC minus OC cancel out, positive PC, negative PC cancel out again, and then we are left with your 2 OC PC. Okay. Now if you look at the sketch again, I'm going to erase this part. Now let's look at the sketch again, right? If you look at the sketch again, right, this OC is this part. OC is X, OP plus PC. OP is equal to X given on the sketch, and PC is equal to Y. So we can write this X plus Y instead of OC, and PC is equal to, as given on the sketch, Y. So we can write in the next step, which is 2x plus y, and PC was equal to y. So this is what we can write in the next step. And then if we multiply this whole thing, in the end you will get 2xy plus your 2y squared, hence proof that kc squared is equal to 2xy plus y squared, plus 2y squared. Okay, now we are going to discuss angles at the center. Okay, so angles at the center. The theorem says angle at the center is twice the size of angle at the circumference subtended by the same chord or the arc. So this is the arc here. This is the arc. Sorry. This is the arc. And this arc is subtending this angle as well as this angle, right? So this angle, if this is x, then this will be equal to your 2x. Okay, so that's what we mean when we say angle at the center is twice the size of angle at the circumference subtended by the same chord or same arc. So we can use an analogy that this person is sitting inside the house eating pizzas and playing PlayStation. That's why this is 2x fat, and this one is outside the house playing in the field. So this one is x, half the size of one sitting in front of the PlayStation and eating and playing games. So if inside it is 2x, then the angle at the circumference will be x. Now the abbreviation that we use for the exam is angle at the center is 2 times angle at the circumference. Okay, so the next two corollaries are very important. This is number one. So the number one says angle on the circumference subtended by a diameter is the right angle, and the abbreviation we use is angle in a semicircle. So this is the diameter of the circle AB, and this AB is subtending the angle C at the circumference. So this will be equal to 90 degrees. This is what the corollaries mean. Now the next one, if we look at arc AB, it subtends arc C and RD, and they are equal. And if we look at arc AB here, this arc subtends angle C and angle D. So again we're gonna say angle subtended by a chord or the arc of a circle on the same side of a chord or arc are equal, and for this one we are going to say angle in the same segment. So this will be reason that we are going to write in the exam. And usually, when there is no midpoint in the question in your exam, then this is the theorem that we use, angle in the same segment. Now we are going to discuss the corollaries related to theorem 2. So number 1 is equal chord of a circle subtend equal angle at the center of the circle, and the reason you can give is equal circle, equal chord, equal angles. The next one is equal chord of a circle subtend equal angle at the circumference, and the reason you can give here is equal circles, equal chords, and equal angles again. The next one is if the angle at the center of a circle or of the same circle are equal, then they are subtended by equal chord. And the reason equal angles, equal chord. And the last one, if the angle on the circumference of a circle are equal, then they are subtended by equal chord. And the reason here you can give is equal angles will subtend equal chord. So equal angle, equal chord. Okay, now we are back to our cheat sheet and the theorem that we have covered so far. Number one, line from the center perpendicular to the chord, then line from the center to midpoint of the chord. Angles at the center is equal to 2 times angle at circumference. Angles in semicircle as well as angles in the same segment. So these are the things and type of questions and theorem 1 and 2 we have covered so far. Now let's look at some of the questions. Okay, so the first one, if you look at this diagram, you'll see this is the arc AB and this is subtending angle O, AOB, and angle ACB. So this one is at the circumference, this is the thin one, and this one is in the center, this is the fat one, right? So this arc AB is subtending two angles. So the x will be equal to half the size of the angle at the center, which is 70. So 70, half of 70 is 35. So the first example, x is equal to 35 degrees, and the reason we will give is angle at the center is equal to 2 times angle at the circumference. Now let's look at this question. This one, again we have this arc AB. AB is subtending this angle at the center, which is x, and this angle at the circumference, which is C. So angle, the arc AB is subtending angle AOB and angle ACO. The circumference one is a thin one, and the center V is it is twice the angle at the circumference. So we will say angle X is equal to 90 degrees, and the reason angle at center is equal to 2 times angle at the circumference. Then this one, you will see that O is the center because of this dot here. This is representing that O is the center, and AOB is the diameter. Any angle that is subtended by the diameter on the circumference is equal to 90 degrees. So this angle here is equal to 90 degrees. Angle A, C and B is equal to your 90 degrees. Therefore, we can say in the first step C is equal to angle C is equal to 90 degree. The reason angle in the semicircle, and then we can apply to find the value of X. We can apply the rule angles of a triangle. So angle inside the triangle is equal to 180 degrees. So we're going to say 90 plus 50. Whatever answer you get, you're going to subtract it with 1 from 180, and x, you will get the x is equal to 40 degrees Celsius. 40 degrees. So C is equal to 90 degrees angle in semicircle, and x is equal to 40 degrees, and the reason angles of a triangle. Okay, the next one is this one. So if you notice in this diagram, angle the CB, this line is a chord, and this line is subtending this angle as well as this angle. So this angle is at the circumference, angle A is at the circumference, that is 30 degrees, and angle O is at the center, which will be the double of the angle at the circumference. So in this case, angle O will be 60 degrees. Now 60 degrees. Now next step will be to notice, it is very clear that CO, the line CO and the line OB is a radii, right? Therefore we can say, okay, therefore we can say that this line OB and OC are equal, making this angle equal to x as well. So if this angle is also equal to x, then we are going to say, okay, angle sum of triangle is equal to 180. So we're going to say 180 is equal to 60 plus 2x, and then we are going to solve for x, and which will give us x is equal to 60 degrees. So starting with finding the angle O, COB is 60 degrees. Reason, angle at the center is equal to 2 times angle at the circumference. Then x is equal to B. So angles opposite angles of the angles at opposite side are equal to the sides, and then 180 degree is equal to 60 degrees plus 2x, which is angles of a triangle, and then x is equal to 60 degrees. This is the next example. Okay, now this one, if you look at these two lines, the line DB and this line, this is the parallel line. So we can say angle D is equal to 75 degrees. Why? Because of the alternate angle between the parallel line. So 75 degrees, and then if we look closely again on the diagram, this is the arc AB, and this is subtending this angle DFB. and angle C. This means that angle D and angle C are equal. So angle C will also be equal to 75 degrees. So we can write it like this: D is equal to 75 degree alternate angles, and X then will be equal to 75 degrees angles in the same segment. Okay, now this question to find the X. So first we can clearly see there is a triangle, so we can start with what's given, right? So this is the triangle. If I can highlight this part here for you, this is the triangle, right? We can find the angle C by applying angle sum of triangle. So we can say 180 minus this angle, 26 plus 37 minus 180 degrees, and that will give you the angle C, which is equal to 117, which will be equal to your 117. 117 degrees. So this is the angle. Now this is the straight line here. This is DE is the straight line. So to find this angle, we can say 180 minus 117, which will give us 63. Right, so the reason will be angles on the straight line to find the angle OCD, and then after that we can say, let me erase this. If you look more closely on the diagram, this is the arc BC we can identify, and this is subtending this angle as well as this angle. So angle D is also equal to 26. Now we can say exterior or angle of a triangle is equal to the sum of interior opposite interior angles. So 63 plus 26 minus will give you 63 plus 26 will give you 89 degrees, and this is how you are going to write your answer for this one. ACE is equal to 117 angles of a triangle. OCD is equal to 63 degrees angles on a straight line. BDC is equal to 26 degrees angles in the same segment, and then X is equal to 89 degrees exterior angle of a triangle. The common mistake that children do here is they say they consider DA as a arc, which is correct. DA is a arc which is subtending this angle X and this angle E, right? But X is not the center. This is always the center, and the DFA is not in the center. So we can't say that this, if this is 37, this will be twice 37 times 2. We can't say that for this one, right? And this here is not on the circumference. So that's why also we can't use that theorem. And that's why this is the long steps we have to follow to find the value of X. Okay, circles S and circle R intersects at B and D. ABC and ADE are double chords so that angle A is equal to C1. Prove that D1 is equal to C1. So the first step is S1. If you see this, S1 is equal to 2A. So this is A. Why? Because this is the arc BD, which is subtending the angle S and angle A, angle S at the center of a circle and angle A at the circumference. So the reason is angle at center is equal to 2 times angle at the circumference. Next step, this angle D1 is equal to angle A plus C1. So you see this CD, DA and AC is a triangle. So this is the exterior angle of the triangle DCA. So we are going to say D1 is equal to A plus C1. Then this means C1 is equal to A, right? Then we are going to say this means D1 is equal to 2A, and therefore D1 is equal to S1. Hence proved that D1 is equal to S1. For the next question, R1 is equal to 2S1. We are going to say R1 is equal to 2 D1. Why? Because of the angle at the center is equal to 2 times angle at the circumference. So this is the arc CE. CE is subtending angle R at the center and angle D at the circumference. Next step, D1 is equal to S1. This was already proven in the previous question. So this is your